Pikachu, I choose you.
Greetings, the Astro30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. That'll be excellent. Thanks. Today I've got another kit to build. It's a Short Circuits Volume 3 Project 22 Guitar Practice Amplifier. And we'll take a quick look at the schematic in just a moment. It says this low-cost amplifier allows you to practice your guitar without annoying the neighbours. It has a guitar type input socket, small speaker and volume control. Kit includes PCB, 6.5mm socket, speaker and all electronic components. Kit requires 12 volt DC. Use Project 28A, which is a regulated power supply. Instructions are KJ8093. Or the project book, which is BJ8505. I've got the PDF download, so I don't need to pay like 10 odd bucks for a book. And instructions not included. This is a discontinued kit. It's on clearance now, so if you want to buy one, buy it now because they're no longer going to be available. So let's take a quick look at the schematic and I'll go through how that works, and then we'll open this up and have a look.
Okay, and here's a look at the schematic here. This is on page 91 of the book. We've got a wrong way protection diode here, D1. It can also be considered like a half-wave rectifier. Then it goes through the power switch and an LED to indicate that the circuit's on. A 47 microfarad, basically bulk filtering capacitor. And this is a potential divider or voltage reference for the op amp to function correctly. So that's setting the non-inverting pin here of IC1 to around about half the supply voltage, somewhere there. The input comes in here through a 0.22 nanofarad, microfarad, so a 220 nanofarad, 10 ohm resistor, and a 10 picofarad capacitor here to, this will form a low pass filter in effect anyway, and will stop it from amplifying high frequency sounds like anything that can cause it to oscillate. And then we come into this stage here, which is set to a gain of 23 by this resistor here and this resistor here. Just with a stabilization capacitor 330 puff there across the 22k. And this stage is mostly what gives it all of its gain, because then we come through the volume pot and you'll notice that we've got this 390 nanofarad or 0.39 microfarad capacitor here going on the counterclockwise position of the pot to ground. And you may be thinking to yourself, what's the point of that? Well, rather than adding a capacitor here and a capacitor there, they've decided to put it there, so no DC can actually run directly through the pot. However, you're not going to achieve a zero volume with that capacitor in circuit. Basically, it's acting like a tone control, like it was on that practice amp that I was messing around with the other week. Anyway, we then come into part 2 of the IC1, which is, by the way, a TLO72. It's not marked on the schematic, but that's what it is. This is just a standard non-inverting amplifier, and we'll notice that we've got 2 transistors connected as emitter followers on the output pin 7. This is a Class B amplifier. Now, the difference between a Class AB amplifier and a Class B amplifier is their biasing method. Class AB is biased near to cutoff, that is, that the transistors will no longer conduct. Class B is actually biased at the point of cutoff, so that neither transistor is on at any point in time, so the quiescent current is pretty low. The drawback to Class B amplifiers is they're susceptible to a phenomenon known as crossover distortion, where the positive falling sine wave coming back down to the zero line, then you get a little bit of a notch, and then it falls down to the negative cycle. So there's a little notch in between the dead time, we'll call it, when neither transistor is conducting. and that ends up with a crackling sort of sound coming through the output. The way to cure that is what a lot of people do is put a resistor between the emitters and the bases like they have here. And that just employs a little tiny bit of negative feedback, if you want to call it that, just to bring these transistors into slight conduction so they're not at complete cutoff. Without it, you would have severe crossover distortion. Now we'll notice that this op amp here is configured as a voltage follower, so therefore there is no gain in this stage at all. All this really is a voltage to current converter. So it'll, like cash converters, will give you some money. It'll just basically allow you to push current out through to the speaker, which goes through this 22 ohm resistor and this 47 microfarad capacitor to block the DC into the little tiny pissy speaker they give you, and that gives you the output. Now this arrangement here is probably not going to produce a lot of power as in watts. I tend to think that a gain of 23 is too low really, but it's possible that it might work okay. I have to build it and find out. I've never built this circuit before. I've never built it up on breadboard, never built the kit. So that's the next thing we're going to do, is we're going to build the kit and test it out and see how good it actually is or isn't. So let's get going.
Okay, that was a quick look at the schematic. It's pretty simple. It's really nothing to it. So if I can get this thing open, it'd be nice. Right, don't need that. They're useless preamble crap. Buy some more shit from us. Some solder in there, nice. Got another one. A large 21mm pot. I haven't seen a pot like that for years. I've never used them. There's the socket. Seems to be 2 pot washers for some reason. Board mounted switch, which is kind of stupid because the input socket's higher than the switch, so that won't make any sense. But anyway, put that to the side. Another one of these small little speakers, 40mm, the same that was in that Ding Dong doorbell kit. It's catalogue number AS3004. And here's the PCB. Overly large for no reason, but there it is. It's relatively good looking. I'll be using an IC socket here just to allow me to change out the IC, because the original is TL072, but I might try sticking an NE 5534 and 32 in there and see if it still works. Just to see what different op amps do in the circuit. Like, can you substitute? I've got an LM833 as well that I can try. So that's the underside. It's fairly basic. I mean, I don't really like their routing too much. Too many straight lines in my opinion, but I'll set this up and we will build the circuit in time lapse because, well, I can and it's quicker. The LED I'm not going to mount on the board, or I might, I don't know. I'll have a think about that for a while. But yeah, I'll assemble this up in time lapse and we'll come back and test it. Oh, just one thing to note, where the pot lives on the board here, you use PCB pins, or if you can find ones with pins long enough, you can bend them over and actually stick them through 3 holes here. Just keep that in mind. Well, that was relatively painless. It only took me about 24 minutes to build it. I don't really like that pot being mounted to the board like that, although it will work. Probably should have cut the shaft down first. They do supply a knob, so I'll put the knob just sitting on the end there because I've got to be able to pull it back off. In retrospect, you'd probably be better off having this mounted off the board with some wires instead, but it is what it is. Be aware that they do not supply any tin copper wire for these two link wires here, so you're going to have to try and reuse like offcuts of your pigtails from resistors, diodes or whatever you're using just to get the link wires in there. I happen to have a roll of the stuff, so it's not that big of a deal. Just going to pop the TLO72 in, preferably the right way around. Now, I was not going to put that 2K2 resistor in that goes here between the emitters and the bases of this Class B amplifier here, just to demonstrate crossover distortion, but I forgot. I can always take it back out, but I don't think I'll really worry about it too much. Trust me when I say, when you're looking at crossover distortion, here's your zero line, here's your waveform, comes up to a peak, comes back down to the zero, and then you end up with a notch as it goes down to there, back to there. You get this little notch here. This is very common with Class B amplifiers, which is what the purpose of that resistor is to try and correct that as best as possible by providing a little bit of negative feedback back to the bases from the emitters. And a lot of Class B designs employ this technique. But that's what it would look like on an oscilloscope screen. Probably not as pronounced, but what that sounds like audibly is a crackle, like it's a sort of sound, especially with bass notes. It sounds nasty, put it that way. So what I'm going to do is I'm going to set up some test equipment. I'm going to hook it up to the oscilloscope and a function generator and find a way of getting an input in. I can probably just plug this in and find a little plug that I can hook into here. I did end up installing the LED. I thought, well, why not? Yeah, and then I'll hook it up to a proper speaker and we'll have a listen with my bass, I guess. But let me get set up for testing. Alright, everything's set up, 1 kilohertz going into the circuit and 12.2 volts roughly. We're on, and now if I rotate the volume knob on the unit, we can see we're getting a signal, and that's full volume, that's as much as we're getting out of it. And I can get a little bit more going in, but we do seem to have a little bit of asymmetrical clipping here. As we can see, the bottom is clipping earlier than the top, and we're only pushing 676 millivolt RMS out, so rough calculation, that's about 300 milliwatts. Yeah, more like 57 milliwatts, so pretty much bugger all. But that is really the premise of the thing. It's only a practice amp. So alright, we know that the circuit works for what it is. Just going to back that off just so the asymmetrical clipping goes away. And we're more like 607 millivolts, so about 50 milliwatts, which is not a lot of power. That's into 8 ohms. I'm not even going to bother trying it into 4. I don't really see the point. What I will do is I'll try substituting this TLO72 out for a 5534 and see if we still have an output signal. I'll try not losing the footage for this video too, like I lost for one other video. Okay, the 5532 is in. Yeah, we have an output signal. So we can know straight away we can substitute it for any 5532, and we still got that asymmetrical clipping, so that's basically the circuit doing that rather than the IC. Now I have to locate what I did with the LM833. I'm not sure where I've put that. Not sure at this stage, but first I got to go to the toilet. I need to take a dump real bad. Oh, that's much better. And we've got not much current draw happening either, so it's less than 10 nmA by the looks of things. So that's including with the LED glowing. You could probably run this on a 9-volt battery for quite a while. Alright, found the LM833. Yes. We again still have a signal. So great. So yeah, you can basically substitute any dual op amp you want. I think I'll leave the testing there and I'll stick the TL072 back in. And then we'll hook it up to a speaker. Alright, I got the speaker hooked up in place of the dummy load. Got some bleed through. That's because of that capacitor to ground on the pot there. I mean, yeah, it is amplifying. It's just not very loud. Then again, I guess that was the point. So what I'll do is I'll remove the generator and I'll hook up the guitar instead. Alright. Yeah, there's very little power there. That's full up and I can barely hear it. Then again, my pickups do have that issue too. So, yeah, anyway, it does work. Is it the best? No. But it works, nonetheless. So, I think this is where I'm going to leave this video, is right here. Because there's not much more I can really do. The gain could probably be improved by altering the gain at the front end, the preamp. But I just don't have the time to make the effort to even do that. So, but if you enjoyed this video, please remember to go down below, like, comment and subscribe if you haven't done so already. And as always, this is the Astro 30 saying, see ya, have a great day.